It's your boy, Mr. Siegel, doing 6.2 Properties of Parallelograms. It's about to go down. Let's do it. A parallelogram, what is it? A parallelogram, all right, is a quadrilateral, and I'm not sure if you remember what a quadrilateral is, but just to remind you, a quadrilateral is a four-sided figure. So a parallelogram is a four-sided figure, four sides, where both pairs of opposite sides are parallel. Oh, that makes sense. Parallelogram, and the sides are parallel. So we know that ABCD is a parallelogram, and so that means that the opposite sides must be parallel. So that would say that AB, all right, is parallel to DC. All right, if this is a parallelogram, opposite sides are parallel. And not only that, we know that AD is parallel to BC, and that is what makes this a parallelogram. Just to write that down, opposite sides are parallel, so we know AD is parallel to BC, and AB is parallel to DC. All right. So, if opposite sides are parallel, then it is a parallelogram. Now, there are some properties that are true for every parallelogram. All right, and every parallelogram has these four properties. You got to memorize them. So first, all right, besides opposite sides being parallel, we know that opposite sides are congruent. All right, so in every parallelogram, our opposite sides are congruent, and let's just show what that looks like. So this side and this side would be congruent, and this side would be congruent. All right, the opposite sides are congruent. This is always true for parallelograms. The second fact we know about parallelograms: opposite angles, all right, are congruent. And what is an opposite angle? An angle, opposite angle, is when they're across from each other like this. So these two angles, if you look at them, these are the two tiny ones, or cute ones. Opposite angles in a parallelogram are congruent. See what I'm doing here? Huh? Across from each other? Yeah, that's true. So if this is 60, we know this is 60. All right, and if this was, sorry, these two would also be congruent. So if this was 120, this would be 120. All right, opposite sides are congruent and opposite angles are congruent. All right, next one. Adjacent angles. No, I wasn't sounding out how to spell that. Okay, I was. Adjacent angles are supplementary. Now, first, it's probably good to know what adjacent means, and that's next to. So angles that are next to each other are supplementary. So for example, this angle and this angle are next to each other, right? They're right next to each other. So they're going to be supplementary. Now, just to show you why, because I think we should probably explore why these properties might even be true, we know that these two lines are parallel, right? And let's just extend those. All right. We're going to extend those lines. So those are parallel lines. And you might remember us talking about this, that this line right here would be our transversal. Now, what do we call these two angles right here? These two that are on the interior. That's right, these are same side interior angles. And same side interior angles are always, that's right, supplementary. So that's why in a parallelogram, same side interior angles are supplementary. Pretty cool, huh? Now, there's other pairs of same side. So if this was, let's say 100, this would be 80, all right? But these two are also next to each other. You see how these two angles are also next to each other? So this would also be 80. And oh, across from each other, they're also congruent. So adjacent angles are supplementary. And finally, our last fact of the day. We know diagonals or bisect each other. So in every parallelogram, the diagonals bisect each other. So if we were to take two nice lines, and you should probably draw this with your protractor right now. If I draw these two lines right like this, what is that garbage? I know these diagonals are going to bisect each other. And what's bisect mean? Bisect means to cut in half. Cut in half, or two congruent pieces. So this side and this side of the diagonal are going to be congruent, and this part of the diagonal will be congruent, right? Because this goes right through the middle, or the midpoint. All right, let's use these properties to start solving some problems, okay? Quadrilateral ABCD is a parallelogram. Find all missing sides and angles. I think we can do that. So before filling this in, let's just fill in what we know to be true using our properties. Well, we know opposite sides are congruent, so if AB is 10, we know DC is also 10 inches, okay? And if we know AD is 7, the opposite side is going to be true, and this is going to also be 7. Well, that's easy enough. The second thing we know is that opposite angles are congruent. So if D is 80, we know B will also be 80 degrees. And finally, remember, adjacent angles are supplementary. So to find out what A is, all we have to do is 180 minus 80 degrees, all right? And that gives us 100 degrees, all right? And now these two are supplementary. So that's how we fill it out. Opposite sides are congruent, opposite angles are congruent, and same side interior angles or adjacent angles are congruent. So let's just use this information that we just filled out to solve this problem. So BC, if we look at that over here, BC is 7 inches. DC, which is over here, is 10 inches. Angle B, we found out was 80 degrees. And angle A, which is over here, is 100 degrees. Wow, look at that. Those properties helped us out a lot. Okay, IJ and HK intersect at point L in parallelogram HIJK. Oh, that's in the wrong order. Mark all congruent segments in the parallelogram and find the length of the following segments. All right, I think we can handle that. So first, let's start with marking congruent segments. Well, we said that these two diagonals will bisect each other. So this and this are going to be congruent, right? Because this is our middle point, and this part of the diagonal and this part of the diagonal are going to be congruent. Now, based on that, we can start filling in some side lengths. So if this is 10 and this is congruent to it, this will also be 10. And if this is 8 and this is congruent to that, this will also be 8. Well, based on that, I think we can start answering some questions. So first thing it asks us is, what's LK? And LK is right here, and that's 10, because these are congruent. Boom. And then it says, what's HK? A little more difficult. That's asking us for the whole thing. Well, to find the whole thing, what do? Well, I just add these two parts together. 10 plus 10, we use the segment addition postulate, and we get 20. Second part of this question, what is Li? Well, we found out that Li is equal to 8. What's Ji? Well, Ji is this whole length, so once again, we're just going to add these two parts together. 8 plus 8 is 16. Woo! And that one is done. Okay, next problem. MO is a diagonal in parallelogram PMNO. Find the measure of the following angles. And what we're going to do, once again, is just start off by finding all the angles and filling this stuff in. So what are we going to do? We know this angle over here is 70. We know this angle is 50. Well, the first thing we can do is this. We know that MN is parallel to PO. All right? Now, this might look familiar in a second. Those two are parallel. And this MO over here, this diagonal, could be used as a transversal, right? So if this is a transversal, what can I say that these two angles are? Alternate interior angles, absolutely. And alternate interior angles are congruent, so this would also be 55 degrees. Awesome. Let's get rid of all that though, okay? So this is 55 degrees. Now the second part of this is we want to find this angle right here. All right? And what we know is that these two angles, these two bigger angles, are supplementary. So to find out this missing part of the angle right over here, what we'd have to do is 180 minus 70, right? We're getting rid of this part. But we also have to get rid of this part, so minus 50. And when we do that, we get 60 degrees. All right? And that makes sense because if I were to add up, well, let's get rid of that garbage again. All right. If I were to add up these two angles, 60 plus 50, that's 110. 110 plus 70 is 180. So now these two angles, once again, are supplementary. Now to find the rest of the angles, remember opposite angles are congruent, so P and N are going to be congruent. So this is also 70 degrees. And finally, we're going to use the alternate interior angle theorem again. So right over here, this angle and this angle are alternate interior, so this is also 60. And now we found all our angles. So let's just fill in what we know now. MNO, that's MNO. Let's follow that around. MNO. MNO. N is our vertex, so that is 70. MOP. All right, let's try that. M to O to P. O is our vertex, and that is 55. NMO. Oh, this is getting messy. NMO, that's this angle right here. NMO, that's 50 degrees. And finally, our last one, OMP. OMP, that's from here, OMP. And M is our vertex, so that would be 60 degrees. A little messy, but I think you got it. All right. Now let's start using the properties that we learned to solve some really difficult problems. And by really difficult, I mean somewhat difficult. ABCD is a parallelogram. Find the value of x and y and state which property you use to solve it. So if you look at this, I want to find x and I want to find y. And I got to set up some equations. And what we could use is that opposite sides are congruent to solve this problem, to set up our equations. So I could say that 2x is equal to x plus 6, right? Because my opposite sides are congruent. And I could also say 4y is equal to 12 because opposite sides are congruent. So by using this property, opposite sides are congruent, I could solve this problem. So now all I have to do to solve for x and y is to solve these equations. So for this one, I'm going to subtract x from both sides. What just happened there? That is annoying. Sorry about that. We're going to subtract x from both sides. And we get x is equal to 6. That part's done. And for this one, we're just going to add 8 to both sides to solve. That cancels. We get 4y is equal to 20. Divide both sides by 4. And y is equal to 5. All right, sweet. Now the skill that you're really picking up here is how to use a property. Which property should you use to solve these problems? Oh, you might sometimes see that these problems change. That's only because I read them like, that didn't make a lot of sense, and then I change them. And hopefully that's on your printout. So anyway, which property we're going to use to solve this, and then we're going to solve it. So PMNO is a parallelogram. Find the value of x and state which property you use to solve the problem. So to find the value of x, we have to set up an equation. And we're trying to figure out what property would help us set up an equation. And if you look over here, well, I know that these two angles are adjacent. And what do I know about adjacent angles? They're supplementary. So I can use the fact that adjacent angles are supplementary to solve this problem. All right? Oh, yeah, you could spell it. Now to set up our equation, when two things are supplementary, remember we just add them up to equal 180. So it's going to be two angles that add up to 180. So we just plug in what we have here. So it's 14x plus 5 plus 35 is equal to 180. Now that we set up our equation, we can just solve for x. So we're going to subtract 35 from both sides. All right. We get 14x plus 5 is equal to 145. Subtract 5 from both sides. We get 14x is equal to 140. And then we just divide both sides by 14. Ooh. And if you follow me over here, that cancels. 140 divided by 14 is just 10. And so that is how we solve that one. And finally, ij and hk intersect at point L in parallelogram hijk. JL is 3x plus 11 and Li is 5x minus 9. Find the value of x and find the length of JL. All right? State what property you used to solve this problem. Now, once again, what property can we use? Now, what do we know about diagonals? It's that they bisect each other. So these segments are congruent. If I know these are congruent, then I could set up my equation as equal each other. So it's 3x plus 11 equals 5x minus 9. And the reason I'm able to set that equation up is because I know this property, that diagonals bisect each other. And I don't want to take up much of your time because this is going a little longer. So what you should be doing is solving this. If you solve this correctly, you should get x is equal to 10. And to solve the problem for what is the length of JL, which is right here, we just plug in 10 for that. So JL is equal to 3 times 10 plus 11. And so JL is equal to 41. All right, guys. Hopefully you got this down. Sorry, once again, the lesson's a little long, but you are the jazz for completing it. So remember, don't walk home late at night by yourself. It's very dangerous.